You should be good to go, darling. Right. Before, so we're expecting who else? Laura, Adam. That's it.
Yes.
Right? Oh, and Michael Katz.
Yes.
Okay. Cool. All right. I'm gonna. My script works. That's cool. I'm gonna head out. I need to give up my.
Yes.
Okay. I'll come up at some point in between. Just my read
Okay.
it.
Yeah, no problem.
Have a great class, guys.
Hi. All right, so how was everyone's weekend? Good? Yeah? It was what?
It was hot on Sunday.
Yeah.
I was in the park. It was very sweaty.
Yeah, I know that feeling. Anyone go anywhere? No? Downtown, that's super exotic. You'll have to show us the pictures.
I went to a basketball park. Hopefully that was kind of dumb.
Yeah. Yeah, we didn't do anything special. Oh, that's even more.
Yeah.
Wow.
Very funny.
What wanderlust. Okay, so I'm sure this is not as exciting as Brooklyn, but today, lecture 3 will be finishing up that last section of conditionals and then going on to lists. So Taki and I talked about this. Lists is actually a really long topic. And then for next lecture, we'll be doing dicts, which is shorter. So what we're going to do is I'll go over homework 1 next class because it will fit better. And then that way we can get through more of lists today. So if you just open up the notes for conditional statements, which again, if you go right to lecture 3, conditionals, here we are. I always forget that projecting makes it so much smaller and I'm blind. Here we go. Everyone else can see that, right? Okay.
Yes.
All right. So conditional statements. We've been doing conditional statements pretty much since the beginning of class, whether it's been in the form of pseudocode or comparison operators, logical operators. So this should be pretty simple. It's basically just the syntax, which comes, okay, after that conditional expression, what do you do? So here is the most basic example, if true and if false. These by themselves, you would never really write something like this. This is just to show, here's where your expression would go and ultimately what it would evaluate to, either true or false. So in that case, if it's true, you would do this, whatever the meat of this statement is. And if it's false, you will never run this statement. So it's if, whatever your expression is that evaluates to true or false, a colon, and then make sure to indent. Colab, by the way, is really, really picky about indents. If the indents are not all exactly the same size, it will throw an error. So just be aware of that when you're debugging and you're like, what is wrong with my code? It could easily be that, not your fault, just collab. Okay, so as I just said, conditional statements are basically made up of all the logical expressions that we've been studying up until now. So here's a really basic example where you've got the temperature outside is 43 degrees, and you want to write recommending when to wear a jacket. So you write, if the temperature is less than 65 degrees, print wear a jacket. So because this 43 is less than 65, it will evaluate to true, and you should expect this to print out, which it does. On the other hand, if it's 87 degrees out, you expect it to evaluate to false, and it should not execute this code, which you see that even if you run it, it doesn't do anything. Here is just an example to show that you can chain these expressions just like we practiced in the last class. So you can say, okay, if is it raining is true and temp is less than 65, print wear jacket and bring an umbrella. Which works because these both evaluate to true. So I'm going to come back to this in a minute, because obviously if you changed one of these up and only one of them were true, you might want to write some other conditions. Like this is just one use case. Else's and elifs are where you can bring in the rest of the use cases. So else is kind of saying, okay, we have this one condition. If it's less than 65, we're a code. Otherwise, in all other cases, you won't need a code. And that's where else comes in. Else is really simple, no conditional expression needed, just else, colon, and then some indented body of whatever action you want to execute. Yes?
Could you theoretically have no indentations?
No.
Why not? What if there don't have any indentations everywhere?
Anywhere? Sorry, what was the last?
What if you had 2 indentations? Would that work?
I
Like,
doubt it. Python is really, maybe the 2 indentations works. I don't know why that works, but
okay, so the else doesn't have to have the same amount of indentation?
I mean, technically for best practices, you should. I think maybe collab is just here, indentation error.
So you need the indentation.
You need the indentation, although I never even thought like, if you have 2 indentations, if you have more than you need, I guess it still interprets it. But then again, when you are writing a more complex body of code in here, you might have even more indentations for things you're nesting inside. So it's just best practice to, yeah. But good question. That's just the colon to signify that it's the end of the if statement or the else statement in this case.
How do you end the condition, like the responses? I think the question is like, if you have an if statement, and then you like, if statement is over and you like continue, how does it know that the rest of your code is not part of the if statement?
So basically, that's where the indentations come in. So like, how this one works. So 43 degrees is definitely less than 65. Because it's true, it executes that. It knows to skip the rest of this conditional statement because the first one was already true.
But
And then if you have code underneath, which is what I think you're asking, right?
Well, I guess my question is, if you indented the else, would it only do the else if the if is true? Which I guess that's what you can't test.
Yeah, no. Syntax error, invalid syntax, and I'm pretty sure that has to do with the indentations. But you can mess around with this on your own. Like, I'm sure there's a lot of different what ifs you could think of here. Yeah. You can do that. Best practice is to have it like this just for readability's sake. Right, so then if you get into elif, that's where if you want to say, okay, I have this one conditional statement, and instead of just otherwise for all the rest, maybe there's another group that I want to create and do something for them. So here we have, again, our temperature is 43, and we say, if the temperature is less than 30, wear a heavy jacket. If it's less than 50, wear a light jacket. And if it's less than 60, just wear a sweater. Otherwise, you don't need any layers. So here I have a few questions for you guys about what you think. First is, why do you think it's not necessary to have put in this second conditional statement that temperature is between 30 and 50?
Because it only goes to the elif if the if statement is false.
That's right. And then what exactly, like if we had some expression in the else statement, it's implied here, but if we had it, what do you think that would be here? Yeah. Yeah. So that's basically what Python, like it's implied here, but Python takes it to mean else, if it's not any of these, which in this case would be greater than or equal to 60 degrees, else do this. Yes?
Does that mean that in all these statements you have to begin with like the first explicit case and then expand?
Yeah, yeah. It's all about context, I think, and when we get into some more examples, you'll see that. And then we have a little bonus topic here, which allowed us to create some more interesting practice problems for how to generate random numbers. So Python, one of the reasons it's so flexible is because it has its main library, and then it has a bunch of little plugins or add-ons called packages and modules that you can import in order to gain that extra functionality. By not having them all in one in the first place, it keeps Python light and agile. But then, of course, sometimes you'll need them ad hoc, so you can import them that way. Random is one of these modules. All you have to do is literally put at the very top of your code, and always at the very, very top, just for best practice, so that you can check what modules you have imported. Import name of module, import random. And then what you can do is you can look in the Python docs, but random contains a bunch of different functions that you can access within it. One of which is the randint function, which allows you to say, generate a random number, one single random number, between some lower limit and some upper limit. So notice here, though, that you have to reference the module from whence it came. Otherwise, you know, it just gets into like, it could get confused with other global functions that have the same name. And we'll see some examples of that as we move forward. But basically, what we wrote here is just generate a random number between 1 and 100. A simpler way to do this, and this is pretty much how I always do this, if I know that I'm only going to import that one function, I only need that one function, you can say from random, import randint. So number one, it keeps your library lighter because you didn't import the whole module. And number two, then you don't have to reference random when you call that function every single time. So it just makes it easier. That's what I like to do. And it does exactly the same thing. Although obviously there'll always be different answers because random numbers. Questions? Yes.
This 2 times you said
Yeah, every single time it runs, it generates a different random number, and you stored it when you ran it, but once you run it again, it wipes it, generates a new one, and yeah. All right. So I created one for us to practice together with random numbers and conditional statements. The popular coin toss problem. So if you're doing some probability experiment, and the simplest one that they always give the example is the coin toss, right? 50-50 odds. So here what we're going to do is randomly generate either a 0 or a 1 to represent the outcome of the coin flip. Let's say 0 is heads and 1 is tails. And then based on what the result is, print the appropriate winning outcome. So you'd either print heads or tails. So what do you think we would do here? Yes. And the syntax for that is from random, import randint. So here's the part we just went over, but that you have to think about the lower and upper bounds. So let's call this outcome, I guess, for where you would generate either the 0 or the 1. How would we do that? Mm-hmm. And then, but what would the bounds be?
0, 1, 1.
Are they inclusive or exclusive? They're inclusive.
Inclusive. Which is important to remember because, as we'll see later, when you reference ranges like this, they're not always inclusive.
That question, you do like negative numbers here too. So I did like negative.
I think so.
100, would that be 200 available things? Yeah, 0, yeah.
Yeah. I'm pretty sure you can do that.
Yes.
Yeah.
Cool.
All right. So back to this example. We've got our outcome, and then based on this outcome, we write our conditional statement for which one to print. So what expression could we use in our if statement here? Yes, Adam?
You could say if outcome equals 0.
And remember, it's equals to show equality
And
with the colon at the end.
then print this
Yeah.
else.
Perfect. And then that's the program. It works. And then I did just a little extra. I made one so that if it lands on the edge, you could have that. And it prints the outcome of the flip. I did this mainly to show an elif statement, how you would incorporate that here.
Isn't there no bounds? Flip.
I guess it also, if I would say like there's something really weird.
Like that
Yeah.
one, it still has your.
Yeah.
Which the randint, yeah.
Yeah, when it never print.
You're right too.
It won't, but
Okay.
just to illustrate this, that's why I didn't include it in this one. Okay.
It's like, even if it's technically impossible for them to save the news, like your program randomly.
Yeah, I mean, it's
Backup
always
safety.
good to have a fail-safe in
Yeah,
place, just in case.
You never return.
I definitely would.
Yeah.
Yeah, there are ways, which I actually don't know how to do, but you'll learn later on with talk, to raise errors so that you can put else if it didn't work with any of these conditions I expected, raise this error.
Right. Okay. Last question. If you have elif, do you need to have everything else? Or can you like just end with the elif?
No, you can,
Good practice.
yeah.
Yeah.
yeah. If you don't need it,
Right. Cool.
totally fine. Okay, so I have 2 practice sets for you guys. We'll do one at a time. And I think what we're gonna try is, I wanna make sure that the class keeps flowing at a good pace. I wanna make sure everyone has time to do the problems, but I also wanna make sure that, we keep moving and get through the content. So if everyone just opens up the P set, the link to the P sets, we did weather last time, so we're gonna do the logic problems, 1, 2, 3, 4 this time. And what I'm gonna do is I'm just gonna set timer for 10 minutes, and we'll go over these 4 problems first, and then we'll move on to random numbers.
Is it attached to that index?
One indent. It's 2 spaces. Colab does by default, so you can also do it that way. I set mine, the preferences, so that Colab expects 4 spaces. Bless you. Bless you. It's contagious. How's everyone doing? Awesome. Bless you. Okay. Where is everyone? Just to get a sense of, like, how far did you guys get? The second one? Others? Ready? All right, how about I go through the first two to start right now? Okay. So calculating a grade. Basically just taking a number grade and based on whatever it is, converting it into a letter. So I just chose the grade 93. Based on this, you want to do, if it's between 100 and 90, print A. And this is, just the grade scale that everybody knows. If it's less than or equal to 89 and greater than or equal to 80, B. And then for C, D, F, just the same for the 70s, the 60s, and, well, for F, it's anything lower or equal to than 59. I guess you don't technically need the greater than or equal to 0 because you wouldn't get a negative score ever, but yeah. Did anyone have any questions about this one? Yes.
If you want to specifically on like all-around school studies, like how would you, because grade is a huge area.
Oh, if you wanted to specifically call out, what did you say? Sorry.
Like the last one,
Uh-huh.
Because it would require you to put in strings for the grade.
Uh-huh.
So like, would you then have to like find like your grade, it would be like an integer or a string.
So,
So like if we update line number 5, grade equals L school stuff,
Mhm.
it would probably.
yeah,
Oh,
yeah.
okay.
This will only work if grade starts off as some number. It could be an integer, it could be a float. But you're not converting anything here, so otherwise it wouldn't give you any sort of type error. Adam?
I was just wondering if there's a reason to do it in this direction instead of in the opposite direction. Sorry, like less than 60.
Optimism. You hope that more of your students are smart. You hope that the majority of them will be stopping around here and you're not gonna get to F. That's really it.
Like grade 89 greater than or equal to. I just had like grade greater than 190, grade greater than 80, grade greater than 70, so on.
I did this just in case they got any of these. If you do greater than, you're maybe
Actually,
skipping.
I was thinking for the first one because then 10,000 given A. Oops. Yeah, okay.
Yeah,
Yeah, okay.
yeah. But that's like how at the bottom I said, oh, you probably don't need greater than or equal to 0 because you're not going to get a negative. Like, if you get a negative grade, it's just implied. It doesn't matter.
Extra credit, you could get over.
This is true. That's true. Maybe I'm just a mean professor. Maybe I don't give extra credit. Okay. So the second one kind of brings us back to Adam's question from a while ago about the order in which you do the conditional statements. So for this one, we're saying, okay, we have 3 numbers, A, B, and C. They could be any numbers. And we're trying to figure out what the sign of their product would be, like if you multiply them all together, without actually multiplying them. So basically that uses the logic that if there's an even number of negative numbers, their product is positive. If there's an odd number of negative numbers, their product is negative. So here you would sort of break it into 3 different levels. You would start with A and you'd say, okay, A can either be positive or negative. And that's the first level of conditional statements. Then you break it down and say, okay, if A is negative, what about B and C? So then you break it into that second level of, is B negative or positive? And then below that, C negative or positive. And based on that, you print -1 or +1. And then you just do the same thing for if A is positive. Break it down into B and then C. Pretty much a problem about permutations. How many different, actually combinations, because order doesn't matter here. Everyone got this? Super. All right. How many people got to problems 3 and 4? Okay, I'm gonna go over 3, and then we can take another 10 minutes and do problem 4 and then random numbers, and then we'll go over those. Okay. So problem 3. This one you had to look something up for this one. It's basically saying, given some random string, check if there are any uppercase letters in it. So for this one, we're given these 2 strings. And you would just write, if string 1 dot is lower equals true, print y. Now what is lower does is it evaluates whether all the letters in that string are lowercase. If any of them are uppercase, it will be false. So string 1 here should be false, and then it would go to the else statement and print n. So let's try that. Here, let me comment this one out first. Make sense? Okay. For the second one, because it is already all lowercase, the dot is lower would look at this and say, yeah, all of these are lowercase. It's equal to true. So then we'll print y. Cool? All right. So why don't we take another 7 minutes and do problem 4 and then problems 1 and 2 in the random numbers section. Sure. So I'll set a timer. 1-minute warning, and then we'll go over the last of these. All right. Everyone ready to jump in? Okay. So problem 4 from the last P set is empty strings. And we actually learned about this in our last lesson, the strip function to remove trailing spaces. So all we had to do here is, given any string with any number of spaces, if stripping it means it's equal to just the 2 apostrophes, which is basically an empty string, then print true. Otherwise, print false. Otherwise, because like we talked about last class, even if it has these spaces, it still has a length. They count as characters. So they're not, technically speaking, considered as empty. And as you see, in this case, it is true. And because Colab is weird, it printed out my comment. Everyone understands the dot strip? All right. Moving on to random numbers. Generating a traffic light. So as we talked about before, you have to import a random package from random, import randint. That gives you access to the function, the randint function, which generates a random number. In this case, there are 3 things to represent, versus in our example with the coin toss, we had either heads or tails. Now we have red, green, yellow. So we assign 1, 2, 3. And we generate a random number from 1 to 3. And that's what this is here, the randint 1, 3. Lower bound is 1, upper bound is 3, inclusive. And you just write your conditional statement. If randn ends up being 1, print red. If it's 2, print green. If it's 3, print yellow. And this should be Alex. Here, the order of these conditions doesn't really matter. Okay. And then similarly, generating a phone number with an area code. So here we do the same thing, bless you. From the random module, import randint. And here's the format we want. I'm just gonna highlight this like this. So a couple of conditions here for your answer. You want it to be a string. You want to use any one of these area codes just to, keep the number of combinations down. If it doesn't have any of these area codes, pick one of the above at random. So for instance, if you were getting user input and their phone number didn't have one of these, you would replace their area code with this. Or in this case, where we're randomly generating the area code, if it generates something that is not equal to this, which it looks like in this case it never will, here, that should be better, then you would change it to one of these. So string underscore here, we're just going to be 1 dash because that's the code for US here.
Wait, why don't you need the random
Oh, because here I directly imported randint from random. I specified that I'm looking for this specific function. You do that basically just to save yourself the problem of having to reference it every single time. Just a simpler way of doing it. Yeah. Oops. Yeah, well, oh, it doesn't like my comment. Well, I need to. Right. So you've got the 1 dash from up here. If we're going to do the same thing as we did before, have these represented by 1, 2, or 3, generate a random number from 1 to 3. So here, if it turns out that it's 1, make it 718. If it's 2, make it 646, etc. for 212. And then you would add some random number between here. You would do the 3 digits, any 3-digit number. Or for the 4th part, any 4-digit number.
The plus equals adds the value
Yes.
to the correct data bank.
Yeah. It adds it, it concatenates it
Yeah.
in such a way that you're assigning it without deleting what was already in string. Yeah.
You have different names and never pull phone number like 001. Because it starts.
Yeah. Yeah. Just for this example's sake, we're using these 3. Just for the,
Even in the browser.
yeah.
You want a 3-digit number, like that starts with 100.
Mhm.
So you technically would do like 0 to 2.
Yeah, that is a very good point. I'm sure there is a way to do that, but in this case, because if you just put 0 here, it would just give you like 9 instead of 009. For simplicity's sake, we just use this. I'm sure there is a way to do that we could figure out.
All
If they
7 or all 9 digits, or 10 digits, like separately.
Oh, I was thinking, call the numbers, but then like if they have less than just like 3 digits.
Mhm.
Condition to add on them.
Yeah, you know what? I don't want to spend too much time on this right now,
Yeah.
but I'm happy to look at that and solve it after class with you if you want. Okay, I'll make a note of that. In this case, why don't we take our break a little bit early so that we can start back up at 7:27, and we'll dive into lists. And I'll update our agenda. We're a little bit behind, but always better to just make sure people understand the content before going further. Yeah. This one? That's kind of what we did here in this last line, where you want a specific number of digits. So you bound it between the smallest number that has that number of digits and the largest number that has that number of digits. No, there's no way to be like generate random number and put in 4 for I want 4 digits or something like that. That doesn't exist. That'd be cool, but it doesn't exist. All right, we'll just wait for Royce to get back and then we'll move on to lists. Problem 1 in this one? Yeah, of course. In fact, I will make this public and I'll send you the link so you can like reference it. Anyone can reference it. I'll put it on Slack. All right, I'm pasting that link in the general channel in Slack right now. All right. So if you want, you can go over those any time on your own time now. And if you have questions, again, you can always ping us. All right, let's start lists. Lists are one of the best things, I think, about Python. It's basically, it's very self-explanatory. It's a group of pieces of data. Any data, it could be any type of data. It doesn't have to be homogeneous, so you could have a list of strings and booleans and numbers. Each of the items in a list is called a list element. So whereas variables can only hold one item, obviously lists can hold multiple, and that's their usefulness here. Creating lists, there are two ways to create a list. You can either simply directly put in the values between brackets, or you can use the list function and put the values inside the list function. I like to use the brackets. I think they're more straightforward and just cleaner also. So here's an example of different types of lists being declared using the bracket syntax. A note here that this one, just the two brackets, still creates a list. It's just a blank list. So here we go. You can even have a list of lists. So you can nest lists within each other, like here. What? Oh, it's great. It's Inception. Yes, oh yes, absolutely. And as we get into the more advanced topics, you'll see there are other data types that are more like matrices, that are actually built to be able to do linear algebra and all sorts of matrix algebra like that, although you'll not be learning matrix algebra in this class. All right, so the other way to declare a list is with that list function, like here. Again, you can declare a blank list just by putting this here with nothing in it. And it goes like this. The only downside of using the list function to create a list, which is why I don't ever use it, is you can only take one parameter. So if I put in like these three colors and try to make a list out of it, it'll throw an error. It only takes one argument. So basically you have to put these in brackets anyway. And if you're going to do that, why use the list function? Just put them in brackets, in my opinion. But you can do it this way, so worth showing. Here, I'll put that there. The list function, this function here, will only take one argument. So it expects that you only put one thing in. But here we put in three separate things. You would think that that would work, right? But it doesn't. It expects one piece of data that it then turns into a list. Yeah. Yeah. It comes in handy for typecasting. So there are a couple other data structures that are collections of individual data types. So you can use the list function to turn those other structures into lists. And that's where it really comes in handy, more so than defining a list straight up, because you have to put this in brackets still for it to not throw an error.
Okay, and it would print out by
Mm-hmm. Mm-hmm. Yeah. Oh yeah, I put this here for that purpose. Just, it won't let you do it. The one use case that you can do for a list, for creating a list and passing it in here, is if you put in a string, it will actually separate every letter of the string into the list, if you ever need that. Same here. Yeah.
Oh, so it doesn't
It-
separate out by commas, it separates out by.
It here, so if you put in a string, it separates just by a new character. And so here, important to note, like this is just one word, but here this is a sentence. It still counts the spaces as characters. So those spaces are their own individual list elements here. Just, these are like edge cases, but worth understanding.
Why didn't it take the red, yellow, green, and the
That was 3 separate strings separated by commas, whereas this is one single string. So it takes one argument, it will accept one string, but not 3 strings. Yeah, you would think it would. I think that's counterintuitive that it doesn't, but I didn't write Python. So if you want to access specific elements in your list, they are organized by what we call an index. Basically, they're enumerated. But what's really, really important to remember here, key takeaway of the whole day today, is the index starts at 0. So everything that you reference, you have to remember that, okay, I want the second element. The second element is actually at index 1 rather than index 2. That's why it's so important, because you'll never get the thing you want unless you remember that you start counting the index at 0. So for example, right here, if we have this list of names, we want to print the first item, we reference it, we use the list name, and then in brackets, put the index. Since it's the first element, we use 0 to reference it. That's Brandy. It'll print out Brandy. If we want index 1, you write it like this. Index 4, like this. And that will print out exactly what we want. Okay. If you want to print out multiple items from a list, you basically pass a range in these brackets, a range of indices. And this is called list slicing, because essentially it passes back a subset in its own list. So here we have the same list of names, my class, and what do you think this is going to print out here? Sorry? It will print out index 1 through 4. Yeah, yep. Here, though, this is not inclusive.
It's inclusive
Yeah.
on the left and exclusive on the right.
Yes, because why not? Because why not?
That explains so much about what I'm writing here. Like, people I work with do.
Yeah. Yeah, it's inclusive on the lower bound, but exclusive on the upper bound. No, because remember with our randint function, both ends are inclusive. So it's just, you just have to remember which ones are which. Yeah, it's fun.
And I tried out like 1:1 that gives you an empty.
Yeah,
Maybe that's
so
the reason
I-
why, in case you did wonder if you do that. But yes.
maybe. I put a bunch of other use cases down here like that, where you can make it a little bit more dynamic. Like you can say just whatever the beginning of the list is, although it would always be 0, to some index. You can use that. Or some index to the end of the list, which makes a lot more sense because you may not know what the last index is. Just that colon will print the whole list. And if you do an index to that index, because the top is exclusive, it'll print nothing. Which is a little weird to me because like we just said, it includes the bottom number, but then you're excluding it in this second statement too. So it's like, But
Do you think that's because of the order of them, or is it just?
Probably,
Last
yeah.
takes precedent?
Remember, it's an interpreted language. So it's interpreting this in real time. It says, oh, this second thing, the latest thing you told me is don't print 1. So yeah. Questions about this stuff? There's lots of practice, don't worry.
Why would you print my class? Why would you do my class bracket?
You wouldn't,
Yeah.
but I figured that someone might ask that, and I wanted to be able to have that case here for you rather than like write the whole thing out. Yeah, PM just mutes all the use cases. All right, and then if you have nested lists, sorry, what was that, Michael?
Starts from 2, starts from 3.
Yeah. Yeah, so if it starts at index 2, it really starts at the 3rd item and goes all the way to the end, whatever that end is. So if you have nested lists, you're basically just adding another level of reference here. So you reference, in here, we've got one list, and in that list, we have 2 lists, each 2 elements long. So you go from the top down. You say, okay, I want to access the first item in the list. In nested lists, here is our variable. So we put 0. That selects this, circus clown. If you want to reference just circus, you then put right next to it another set of brackets and the index of the thing within the nested list that you want to reference. Yeah, and you can, here, I'll put this so that you can sort of see the progression of it. Yeah. So here you can see how, okay, the first thing it selected was this nested list, the whole nested list, and then we went to another level and selected something within the nested list. So if you want to print trapeze, all you have to do here is say, okay, within this parent list, make it 1, index 1, because it's the second item in the parent list, and it's still the first item in that nested list, so you keep it 0, and this would print trapeze. Okay. So I have one for us to practice together here. Here is a list of different types of pets. Yes.
You had 2 spaces in between your second, your line 3, and line 6. Is there a way to have 2 breaks in there to just keep your answers clean?
What do you?
In your results.
Oh, yeah. If you want, you can, what I do a lot is I just put in the break character, that's \n, and then that way it prints out like this. You don't need it, it's just for making it clean. Oh yeah, I totally understand. I do that all the time.
Why did they create
What did it? Oh, I know, because since this is a separate print statement, it automatically goes onto another line. So it did a break here onto a new line here, and then it did the 2 \n, and then it went onto a new line.
This is with the 1 backslash.
Oh, I didn't run it with the 1 backslash. So here's just 2.
Yeah, but why?
Yeah, I'll answer that after class. There is a reason. But for now, let's do this practice. So obviously we'll be referencing something in pets. We want to reference index 1. We put the brackets, index 1. You want to print it. So let's do this. And just for the sake of making this faster, copy this in every line. So this will print cat. Now let's say you want to print guinea pig, ferret. That's list slicing since you're printing a range. So here, okay, guinea pig is 0, 1, index 2. So you go from index 2, ferret is at index 3, but because it's exclusive, you make the upper bound 4. Print the 5th element. Notice here how in the first one I said index 1, and the third one I said the 5th element. So here the 5th element is actually index 6. And then the next line, why index 6? That goes back to the fact that it starts counting at 0. So 0, 1, 2, 3, 4, 5, but this is the 5th. Wait, hold on. 1, 2, 3, 4, 5, 6. And then, yeah. Oh, the 5th element of the list would be 4. Sorry. Yeah, I went one forward instead of one back. Yes. Thank you. Then if you're printing all the elements up to and including ferret, and including, so you want to make sure that your upper bound is 1 above that, you would just put this colon. You don't need to specify the starting bound, and then 1 above ferret. And we said ferret was index 3, so you would put index 4 here. If you want to print dog, dog is the first element of the list, you use index 0. And if you want to print all elements from ferret onwards, ferret, as we said, is index 4, and we do the colon, and we can leave this open-ended. So here, let's check our answers. First one prints cat, as we expected, index 1. Second one, here, hold on. Actually, I want to just, so that we have this to reference with the answers. Closer to them. Here we go. Okay, so printing index 1, that's cat. Printing guinea pig and ferret, we did index 2 to 4. That's how that came out, so we were right. Print the 5th element of the list, so 1, 2, 3, 4, 5. Bird is 5. By putting in index 4, we got bird. Print everything up to and including ferret. We did just the open-ended index up to 1 above ferret. And then to print dog, we determined that, okay, that's index 0, got dog. And then everything from ferret onwards, oh, look at that. We did 1 above ferret. Let's see, 0, 1, 2, 3. Yeah, so we were using ferret 4 so much, I got that in my head. So you would make it 3, which is the index of ferret, inclusive, and then the open-ended range. Questions on this stuff? There will be a lot more practice, so you'll get really annoyed with it eventually. All right. Leave this open, and we can move on to manipulating lists. So I think honestly the hardest part of lists is this selecting slicing. The rest of lists is just different functions, remembering different functions for how to add things, remove things, update things. And it's just remembering those functions. So what I've done, I'll skip a little bit ahead. At the very bottom here, I made a table that summarizes all of these down here. We're also going to go into tuples and sets, which are those other kind of collection data structures. So I summarize everything down here. But otherwise, the rest of the lesson is just memorizing those functions. So for lists, if you want to add items to a list, you can either use .append, .extend, or .insert. The difference here is for append, it takes the last element, or just the element that you're appending as a whole, and it adds it onto this list. So here, if you do .x_append the list EFG, it will take this as one big chunk and put EFG as the last list element in X. Extend will iterate through each one of these items and add them individually to the list. So it ends up looking like this. Append adds this as one chunk, and extend adds them individually. Insert, on the other hand, oh, here's another good. If you pass them within a var, here's another good example. So this one, Y, it put this whole A, B, C, D. No. Oh, I don't want that. I want X. All right. So here it put the whole thing of Y at the end of X in one element of X as a chunk. Whereas using extend, it went down one level and put each element within Y in individually. Because Y here contains other things nested in it, this happens to be a tuple, we'll get to that. Yeah, because this contains something else in it, this gets added as an individual item. So if you have something nested in the list that you're extending onto, that nested item gets added individually. You would have to do like nested extending. And there's actually a practice problem where we'll go into that to then add each of these items individually. So that's append and extend. Insert allows you to specify where in the list you want to insert something. Whereas append and extend, you just add on to the end. Insert, you can say, okay, I want some item at this index. So with my class, yes, Adam?
What's the difference between like FMG, parentheses, and H9?
Yes, it's tupled. Thank you for pointing this out. I will go back and change this so that it's not confusing to people in the future. They are not, but we'll we'll go into tuples shortly here. They only have a few differences. Okay, so insert, you just specify the index. Let's say I want to insert the name Sanju. I want it to be specifically at index 1. So here he is at index 1. Removing items from a list, you can use pop or pop index, kind of the same thing as append versus insert. Pop adds it at the end. Pop index allows you to specify where or what index the item that you want to remove is. So for pop, if we do this here, my class.pop, it removes the last item, which is Sano. And then print my class, and it gives you this without him. Versus pop index, you can say, okay, I want to remove the item at index 2. And remember to count from 0 here. Index 2 is Steve. So we should now see Steve and the resultant list without him.
So can you blank, so the last, goes to the last.
Yeah, just dot pop, that takes away the last one. Versus pop index, you specify the index of the item that you want to remove. All right. Editing items in a list. Actually pretty simple. The same way that you access an item in the list, to update it, you reference it the same way you would if you were trying to print it, and then just assign it a new value. So for example, here we have index 1 is Sanju. If we want to change this to Raju, you can put x1 for x at the index 1, and then the new name that you want in its place. You can also do this for slices of them. So for example, and this one's actually a good example here. So x index 4 through the end. Now index 4 through the end is these 3 names. You don't have to replace that specifically with 3 more names. You can replace it with 1 name, 2 names, 10 names, doesn't have to be the same amount. So here you would just see, when this prints out, you would see this list with Chloe and Phoebe added on the end, and Raju. That's all you have to do to edit lists. There are a couple things that you can do if you're trying to, for example, if you receive data in some other format and you want to manipulate it, mush it together, reformat it, you can do things like joining the items of a list. So for example, if you have a list of strings, it only works with strings and not like a list of numbers or a list that has a mix of different data types. But you can join it. This one is actually a really irritating function to stand out because of the fact that, see how usually you do your list name dot function, and then the parentheses. Here you do the argument and then join and then the list name in here. Why? I don't know, to be annoying. Just another quirk of Python to remember. So here, for example, we've got letters, which make up a name. If you want to turn it into a string that is a cohesive name, you would just do these 2, which is basically saying when you join these, don't put any character in between them. If you did want to, you could do like in between each item, put whatever characters you want. But here, we want it to be a single string. So join letters and you print it and it'll be Juliana. Or you could do a sentence like this, and in that case, say you would want to separate it or separate each item with a space character. So if we run this, we'll get this. And these are, I will put the type next to them. Type next to them. And they're now strings instead of lists. Cool stuff. Again, you can only do this with lists of strings. The same goes for splitting them up. So if you have a string and you want to split it up into a list of distinct items, here you would do the list name dot split. Great that they do that contrast there, but whatever. If you don't put any argument within the split function, it automatically splits it at spaces, or like if it's a name, I think it would separate it. No, actually, I don't know what it would do with a name. You know what? Let's find out. Right. Here, it will automatically, by default, separate it at the spaces, but you can also specify some character that you want to parse it by. So it'll basically say, every time I see this character, in this case, a comma, change, like start a new list element. So let's try these. Yeah, it didn't do anything to the single string. Interesting. But like I said, with the others, the default is the spaces within the sentence, or here we specified commas, which I could do better. I could, because they still have commas in between them here. But it basically said, okay, name, comma, email, comma, phone number, and then it separated them out individually. So here, actually, here's why I wanted to, let's just say that they're separated by $3 each field, just to make the contrast of the result a little more obvious. So here we would do, okay, I know that my different fields are separated by $signs. So we do dot split, and your split character is the $3 signs. When you print it, it will still print out this same thing. Better.
If there's a space between all those commas and the y equals, you need to add a comma space to the y dot split, right?
You mean here?
Yeah.
Like if there were,
Like that was a comma space, yeah, and then the y dot split would be space.
yeah. Here, let me,
But it's only $2.
then you would just do dot split $2 signs. Yeah, yeah, that's just arbitrary, whatever your data comes in as, because, you know, let's say you're receiving a spreadsheet of data from a client, whatever their system spit out, you would just take a look and say, okay, here's how we'll parse it.
What if you want to parse them? You just throw a comma and
So that, since that gets a little more complicated, that goes into regex functions, which you may or may not get to in this class, but it's pretty much what it sounds like. Is just like find and replace, and then you would do some conditional statements saying, if you find this thing, separate it this way. If you find this other thing, separate it this way. Does that answer your question a little bit? I know we're not going to go into the details, but okay. So we're asking about the comma space. So let's just replace these with comma space. And then,
if you only had comma, then
Mhm.
space would be
Yeah.
kept in it.
exactly, if you only put the comma here, this, like the second list element would be this with the space.
If you have like $3 signs, split by $1 sign.
It would be $2, yeah.
Well, would it create a bunch of empty sets?
You know, I don't know. We can try that next here. Let's just run this to illustrate this. So yes, that comma space worked. If you only put the comma, it would have that space, leading space. Now let's say,
It creates one.
Yeah.
I don't think so, but yeah, it basically,
Oh. That makes sense.
oh, whoopsie. Oh, I can't see on this screen. It's like much smaller. Sorry.
You're good. I was just like, I feel like
Okay, yeah, I thought it would do something like this, where it sees the first one, skips it, and then,
Assume the dollar
Yeah.
sign to be on the next one.
If you do two dollar signs, and it keeps the last one in the string,
yeah,
or in the list, yeah.
yeah. I thought it was gonna print out this middle one as an actual
Well,
item,
yes, yeah.
but I guess not.
I don't know, if it checks the column itself.
Yeah. Again, just a fun thing that here's where you would have to debug something. So I don't know the answer to this. We would just experiment until we got the right output that we wanted. There are also built-in operators for analyzing lists. These are really, really simple, like for finding the length of the list, summing up all the numbers. Hi. For doing the length of your list, you just put your list name within the length function. So if we use our class again, we would do the number of students equals len my class, and it would print out 4.
String, and that comes with string instead of list.
I think so. Let's try it. Yeah, I thought so. Where this can come in handy a lot, as we discussed above, accessing different list items, you might, but you probably don't know exactly how many items are in your list. And so you can't directly access the item at the last index. So one good way to figure out what the last index is to find the length and then subtract 1. So what you would do is number of students is len my class, subtract 1, and then you could access the student at the last index by putting it in the brackets that we talked about before. And in this case, that'll give back Dasha. And you can do that also with a nested list. So this is wordy here, but what it comes back with is, okay, how long is this first list? -1. It's got 2 items in it, so -1. The index of the last item would be 1. Same thing for the nested lists. So you reference that nested list to find its length here, -1. And again, it's 2 items. So index 1. And then you would reference it just like we did before with the 2 different levels of indices. So you want to reference here the last item in the last list, which is artist. So what you would use what you just found by subtracting from length, reference it in those brackets like we did before. If you print it out, it'll be artist. Can everyone see that? I know that's really wordy here with these. Yeah, absolutely. Okay, so you take it at the highest level, the parent list. You want to find what index is the last item. So you find the length of nested lists and you subtract 1. That gives you the index of the last item in nested lists. So then what you want to do is, okay, I want to reference that last item and I want to know the index of the last item in that element. So you say, okay, here we just found the index of that nested list here, trapeze artist. So you reference nested lists and then trapeze artist, you put in that index, and you subtract 1. So you find the length of this nested list minus 1, exactly as we did before with the parent list. Now you have the index of the last item in this nested list. So if you want to print that out, you just use the first level and the second level. So here we found the index of the last item in the parent list, and you put that here. Here we found the index of the last item in the nested list. You put that here in the second level, and that's how you would reference this very last item in the last nested element. Got that? I know that's like a mouthful, but yes.
What if we wanted to know the length of all of the items in all of the nested lists? To count everything, all the individual items. So I basically, I wanted to print all that to be 4.
Mm-hmm.
Yeah, parentheses.
You would have to go through it with a loop.
Okay.
So
And then you can do okay.
yeah,
Okay.
because you'd basically have to go through each item and say, okay, how long is this first item? Count the number in this item. And you'd sort of, I guess what I would do is start a tally and just add to the tally every iteration. But you would definitely need a loop to do that because it would be far too inefficient to do it this way. Yeah, maybe there's a better way. And that's why Google is your best friend. Honestly, being a programmer is like, there has to be a better way to do this. Let me see what other people did, other people who ran into this problem. And then you might find it. And if not, like there's usually some sort of hack logic that you can use like that to build it. All right, so these other ones are a lot simpler. Sum just sums all the numbers in a numerical list. Obviously, it won't work if it has strings in it. Min and max, find the lowest and highest number in a numerical list. Yes, also only works with numbers. It can be a mix of integers and floats, but just no strings. The dot index function, oh, this shouldn't be that, returns the index of a certain item. So you know the value, but you don't know where in the list it is. So you say sentence.index, the word pig. I used a random sentence generator for this. And it will return the index position of that value pig, which is 2 here. Important to note that if the element occurs multiple times in the list, it will only return the index position of the first occurrence of it. So here, for example, if we use and, because and occurs here and here, by the way, I'm really sorry it doesn't like wrap the strings here. It won't let me do that. But because it occurs twice, it only gives you this first occurrence index position, which is 3. Another very useful one is count, which will return the number of times something has appeared in that list. A specific value has appeared in that list. So we'll look at it with numbers as well as strings. Let's say we want to know how many times 8 occurred within this list of numbers. You do nums.count 8. It will go through the whole list, tally them up, and return the number of occurrences, which is 3. Same here. If we want to use this element, just the word has occurred 3 times. It does the same thing, just goes through and tallies it, the value that you specified. But here, just like a little nitpicky thing to notice is if you want to count the occurrences of a single character, you can do that within a list. So for instance, how many times does you appear in the words sunburned? You can do that in a string, not a list. It appears twice, but you can't do it with numbers here. You also can't do it with, I should have put another example here. You also can't do it in a list. So for example, if I wanted to do print sentence.count E, the letter E, it won't count all the E's within these words. It will only look for an element that is by itself the letter E. So if you print that, or yeah, it's 0. Even though E appears all over, it's not its own distinct element. If you want that, again, you can use a string. It does not work for numbers. So if you want to count how many times the digit 2 appears in this integer, it won't do it.
You can convert it to a string.
I guess you could.
Yeah. Theoretically.
Yeah, you could, but yeah. All right, so I have another practice together for us. This is another coin toss example. So, all right, let's say we're conducting a probability experiment and we conduct some number of trials where trials here is defined as a coin toss. And we're recording the outcomes in a list. And instead of recording them as 0 and 1 here, I recorded them as true and false. So we want to calculate the probability of getting a heads outcome or a tails outcome. So in this case, I did, what did I do? Heads equals true, probably I made that. I don't think I wrote that here, but I will add it. Heads equals true, tails equals false. So I randomly just put a bunch of Booleans in here, for example's sake. And the way to find the probability of one of these is to first count the number of trials that we did. So we would find the length of coin toss. We would say, how many times did heads occur? Heads equals coin toss dot count true, because true is what we said represents heads here. For tails, it's coin toss dot count false. So here, this first part, let's print that out first. We did 7 heads and 7 tails.
How did you just comment out?
Oh, so if you want to comment out multiple lines at once, you can do command slash.
Forward or back?
Forward. Very useful. Yeah. So that just counts them. And then if you want to find the probability, you take the count divided by the total number of trials. So the probability of heads, P heads, is heads, bless you, divided by the number of tosses. Same for tails. Tails divided by number of tosses. And then you can just print that out as well. Bless you. And it just so happens that it's 50-50. I did not make it like that purposely. But yeah, depending on your sample size, you may have gotten something other than 50%. Good? All right. Sorting lists. I think we'll probably get through sorting lists, and then I don't know about tuples for now, but I think we made pretty good progress. So you can sort lists in either ascending or descending order. If they're strings, ascending is essentially alphabetically, descending is the reverse. You cannot sort a list that has different data types in it though, because Python doesn't know how to compare 2 to A. things like that. Obviously, I don't either. So there are two ways to do this. You can use the dot sort function, which is similar to all the other functions that we've used, where you just do the listening dot sort and print it. This is how you would do it in ascending order. By default, it does it in ascending order. So here it is with strings and our numbers and strings. And if you want to do it in descending order, you add reverse equals true within the sort function. So I'll run both of these. And it gives us what we expected. If you do sorted, and there's really no difference between these, except that, here, I'll show you, I'll go through this first and then I'll tell you the difference. So sorted, you put the list name as an argument within the sorted function. So again, it's by default sorts them in ascending or alphabetical order. And then if you want to do it in descending order, you would add a second argument here, reverse equals true. So we'll run both of these. And it gives you the same exact outcome. The difference is, and this is a very slight nuance. Can anyone tell me?
What does he do? Accepted equals number is not sort. Like, number is equals number, not sort. You had the thing before, right? That you like did the wrong thing to do with assignments.
Mm-hmm.
So it like automatically
Yeah.
reassigns it.
Yeah, that's exactly it. So some functions are done in place and some functions are done locally and will need reassignment. Sort is one of those that is done in place. So you can do numbers.sort without reassigning it to anything, and numbers will already then, that essentially automatically assigns it to the outcome.
Is that true for anything like numbers, dots? Or you think about your thing sorts?
So I don't know why Python does this, but it's basically arbitrary which ones are in place and which ones aren't, because it's more fun that way. Yeah, sorted is the opposite, where it's not in place and you have to assign it to something. So basically for that, you just have to remember.
So
Yes. Someone said.
Is that the only difference?
Yes. Other data structures are limited to using sorted and won't work with dot sort, but we'll get into the details of that later.
yes, the original automatically.
Yeah, yeah, that too. So here's the big summary table. You can ignore the right two columns for now, we'll get there. But if you do want a quick summary of the list functions and attributes that we went over here, here's adding, removing, selecting, joining, splitting, sorting. I know that this is like very dense, and so I just wanted to have a way for everyone to reference this really easily. And of course, you can also go into the main glossary on our GitHub page for an even wider reference. Okay, so we have just 7 minutes to go. I think this is a good stopping point though. I would say if everyone could just, you'll get the link to the exit ticket in about 2 minutes. If people wouldn't mind filling that out, that would be very much appreciated. And then for next class, we will just finish tuples and sets, which are much, much shorter, go over homework 1, and finish dicts, which is again, much shorter. I think we should be able to do that. And we'll do some practice list problems as well. Awesome. So the bot will text you that link. I don't have that link, but it'll text you that link in 1 minute. Does anyone have any remaining questions while we're still here, just on anything that we covered today? Okay, TBD. Right. Yeah, no homework for due Thursday. I recommend reading through the content on tuples, sets, and dicts, but not required. Other than that, just please fill out the exit ticket for us so that HR can determine whether or not to keep us.
Thank you.
Have a good night, Adam. I'll see you in 2 days.